Welcome to Cosmic Atlas, where wonder meets science, and every story begins among the stars. In this video, we'll travel back nearly 14 billion years to uncover the universe's oldest light, a faint cosmic glow left over from the birth of everything. You'll learn how this ancient light was formed, what secrets it reveals about the Big Bang, how scientists decoded its message using space telescopes like Cobb, WMAP, and Planck, and why these light echoes might hold clues to dark matter, cosmic inflation, and even the fate of the cosmos itself. So sit back as we peel back the layers of time itself to witness the first light that ever shone, still whispering across the vast silence of space. Imagine peering into the very first moments of existence, not through a time machine, but through something far more ancient and ever-present, a light that has journeyed across all of time itself, carrying whispers from when everything began. This is the universe's oldest light, a relic from the cosmic dawn, a faint glow that still hums around us, invisible to our eyes, yet echoing through every corner of space. What if I told you there's an echo from the Big Bang still rippling through the cosmos, carrying invaluable information about the birth of everything we know? How can we possibly see something that happened nearly 14 billion years ago? Think of it like an ancient photograph, but instead of capturing a moment from your past, it captures the universe's infancy. This isn't just starlight. It's the very first light that ever shone, a soft and subtle glow that holds the key to understanding how everything began. In its earliest form, the universe was not the peaceful, star-filled night we know today. It was a blinding, formless ocean of energy, a superheated fog made of plasma. Electrons, protons, and photons collided endlessly, scattering light in every direction. There was no up or down, no structure, only chaos, pure, radiant chaos. Physicists call this the photon-baryon plasma era, a time when matter and radiation were locked together in a fiery dance. Light couldn't travel freely. It was trapped, bouncing between particles like echoes in a storm. As the universe expanded, it began to cool. When the temperature fell below roughly 3,000 Kelvin, something miraculous happened. Protons and electrons combined to form neutral hydrogen atoms. This event is known as recombination. For the first time, the fog began to clear. Photons, those restless particles of light, were released. They scattered no more. They could finally move through space. That first moment of liberation is called the surface of last scattering, the instant when light, for the very first time, became free to travel forever. And that very same light is still traveling across galaxies, across time, across the silence of eternity. The cosmic microwave background, or CMB, is that ancient light, the afterglow of the Big Bang itself. When radio astronomers Arno Penzias and Robert Wilson discovered it in 1965, they weren't searching for the universe's origin. They were puzzled by a faint, persistent hiss in their antenna. No matter where they pointed it, the noise remained. It came from everywhere, uniform, constant, eternal. What they had stumbled upon was not noise at all. It was the oldest light in existence. Over billions of years, as the universe stretched and expanded, this once brilliant radiation cooled. Its wavelengths stretched by cosmic expansion from white-hot visible light down to gentle microwaves. Today, it glows at just 2.7 Kelvin, only a few degrees above absolute zero, a ghostly, invisible sea of photons surrounding everything. But this light isn't smooth. When we map it with sensitive detectors, we see tiny fluctuations, minute differences in temperature. 1 part in 100,000. Those small ripples are everything. They are the first fingerprints of cosmic structure, the faint blueprints from which all galaxies, stars, and planets would eventually form. Hotspots mark regions where matter was slightly denser, where gravity would slowly pull particles together. Cold spots mark slightly emptier regions, destined to become the vast cosmic voids. This is why scientists call the CMB the baby picture of the universe. A perfect image frozen in time, showing what the cosmos looked like when it was only 380,000 years old. The quest to decode these light echoes has been one of humanity's greatest achievements. It began with COBE, the Cosmic Background Explorer, launched in 1989. COBE's instruments measured the CMB's faint spectrum and confirmed that it matched the perfect curve predicted by the Big Bang model. For that discovery, its creators received the Nobel Prize. Then came WMAP, the Wilkinson Microwave Anisotropy Probe. It mapped the entire sky with 30 times more precision, revealing the delicate texture of temperature variations across the heavens. Finally, in 2009, the Planck satellite took the baton. With extraordinary resolution, Planck produced the most detailed map of the CMB ever created, a glowing tapestry of red and blue ripples, each representing the faintest whispers of temperature from the early universe. From those patterns, cosmologists could read the universe's DNA. They determined its age, 13.8 billion years. Its composition, roughly 5% ordinary matter, 27% dark matter, and 68% dark energy. And even its shape, astonishingly flat, stretching beyond our comprehension. Every pixel of that map carries meaning. It reveals how fast the universe expanded, how matter clumped together, and how the first cosmic structures began to take form. In those ripples, scientists found the blueprint of everything. A cosmic genetic code written in microwaves, waiting billions of years for us to read it. Yet even now, the story isn't finished. Because hidden within the CMB may lie clues to the universe's most elusive mysteries. Physicists are searching for faint, twisting patterns in its polarization, subtle spirals called B-modes. These would be the smoking gun of primordial gravitational waves, ripples in space-time produced during the universe's first fraction of a second. If detected, they would offer direct evidence for cosmic inflation, the rapid, exponential expansion that stretched the universe from smaller than an atom to cosmic scale in less than a heartbeat. The search continues through next-generation observatories. The Simons Observatory in Chile, the South Pole Telescope, and the upcoming CMBS-4 experiment. Each peers deeper into the microwave sky, stripping away foreground noise from our galaxy, listening for those primordial ripples. But the mystery goes even further. Some researchers wonder if anomalies in the CMB, like the cold spot, could be signs of exotic physics, perhaps even collisions with other universes. Others suspect tiny inconsistencies might hint at new particles, new forces, or a fundamental break in our current understanding of cosmology. The CMB is no longer just a relic. It's a living laboratory, a window into both the past and the possible future of physics. When we look at the cosmic microwave background, we're not just observing ancient light. We're witnessing the memory of creation itself. Every photon that left the surface of last scattering has been traveling through the cosmos for 13.8 billion years, passing galaxies and nebulae without ever slowing down. Some of those very photons are striking our detectors right now. They are the oldest messengers in existence, unchanged since the dawn of time. In their faint glow lies the story of how the universe came to be, how energy became matter, how simplicity gave birth to complexity, how chaos became structure. The CMB links everything, from quantum ripples that seeded galaxies to the mysterious dark energy that now drives cosmic expansion. And beyond all the equations and data lies a humbling truth. We are made from this same light. The atoms in our bodies, the stars above, the galaxies that fill the night, all of it emerged from that same glowing origin. To gaze upon the oldest light is to gaze upon the source of everything, including ourselves. So when you look at the night sky, remember that the darkness between stars isn't empty. It's filled with an ancient echo, a whisper from when the cosmos first found its voice. And though billions of years have passed, that whisper still calls to us, reminding humanity that we are not separate from the universe's story. We are the story. The universe still speaks. In echoes of light, in patterns of time, and in the silence between the stars. You've been watching Cosmic Atlas. If this journey moved you, don't forget to like, subscribe, and share the light, so more minds can awaken to the wonder written across the universe.